going to discuss about one of the most important staple food crops, that is wheat. Wheat scientific name is Triticum aestivum and chromosome number is 2n equal to 42. And wheat is world's most widely cultivated food crop. And as we know, it is generally grown in Rabi season, that means winter crop. It is mostly grown in temperate regions, cool season crop. And in India, it is the second most important staple cereal food crop. After rice, first important staple food crop is rice, and it is being cultivated in 29.58 million hectares in India, and the production is 106.21 million tons, and
Excuse me,
productivity
sir.
is 3,000.
Hello.
Yes,
Sir, this data is of this year.
this data is last year's 2019's data,
Okay, sir. Okay, okay. Thank you.
and productivity is 3.3 tons per hectare. It has more protein compared to other cereals, and it is also having high content of vitamins niacin and thiamine. And mainly wheat protein consists of gluten. The difference between other cereal proteins and wheat protein is wheat protein is having gluten, and that protein consists of 16 to 50% of gluten. And wheat ranks first in the world among cereals, both in respect of area and production. And it is called as king of cereals, and the origin is in Southwest Asia. और हम सब लोग जानते हैं कि नॉर्थ इंडिया में ये नंबर वन स्टेबल फूड क्रॉप है. Besides acting as staple food crop for human beings, wheat straw, it is also a good source of feed for a large population of cattle. And that protein contains gluten, which is very essential for bakers. In bakery, सबसे ज़्यादा wheat को use करते हैं, wheat flour को, because it provides structural framework for familiar spongy and cellular texture of bread and other baked products. हम जानते हैं कि बेकरी में बहुत सारे प्रोडक्ट्स होते हैं, ब्रेड, बिस्किट्स या पफ्स, स्प्रिंग रोल्स, उस सब वो सब चीज़ों में ये व्हीट ज़्यादा यूज़ करते हैं क्योंकि उसमें ग्लूटेन रहता है. और flours of other cereals lack gluten, which is why they are not good for bread making. That's why only wheat is used in bread making and biscuit making mostly. And the classification of Indian wheat, generally 18 species of wheat are present, but only 3 species of wheat are economically important in India. First one is common bread wheat, that is Triticum aestivum. It accounts for the area of more than 87% of total wheat production, and it is good for chapati making and bakery products. It is grown in whole North India and some parts of central and southern India. Next one is durum wheat, and that scientific name is Triticum durum. It is also known as macaroni wheat. It covers about 12% of total area. First, Triticum aestivum, it covers around 87%, and this durum wheat, it covers around 12%, and it is mainly restricted to central and peninsular zones. And these grains of durum wheat are bold, lustrous, translucent, and hard texture with more than 12% protein. And this durum wheat, it is good for making suji, semia, spaghetti, porridge, sweets, etc. Next one is emmer wheat, that is Triticum dicocum. It is mainly cultivated in southern parts of India like Karnataka, Maharashtra, Saurashtra. It is a part of Gujarat and some parts of Andhra Pradesh and Tamil Nadu. These grains are long, medium bold, and hard texture. It is more heat tolerant compared to Triticum durum and Triticum aestivum. Here you see this emmer wheat, it is more heat tolerant. That is why it is mostly cultivated in southern India. And this Triticum aestivum and Triticum durum, they are not that much heat tolerant. That's why most probably they are grown in North India. And this emmer wheat, it is richer in protein, about 13%, and beta carotene. As we know, beta carotene, it is a precursor of vitamin A. Precursor यानी कि बीटा कैरोटीन से विटामिन ए प्रोड्यूस होता है. And this emmer wheat, it is used in the making of South Indian dish upma. and it is being cultivated in only 1%. This Triticum aestivum 87% and Triticum durum 12%. Emmer wheat it is less than 1%. Next one is root system. Wheat consists of two types of root systems: primary root system and secondary root system. First, primary root system, it consists of seminal roots. Seminal roots arise from the embryo at the time of seed germination, and they absorb nutrients for nourishing young seedlings. As plant growth progresses, this primary root system gradually dies and replaced by secondary root system. आप ये याद रखना कि प्राइमरी सेमिनल रूट्स होते हैं वो हमेशा टेम्पररी होते हैं, और ये एडवेंटिशियस रूट्स होते हैं वो हमेशा टेम्पररी परमानेंट होता है. सेमिनल रूट्स are temporary and adventitious roots are permanent. And secondary root system, it consists of adventitious roots. They are also called as clonal roots. They arise at a point above the primary root system, and emanate means they are produced from lateral nodes after the appearance of first leaf. And this most of the roots, this root system, it is confined up to top 30 centimeter soil layer. Next, wheat, a transitional zone is present between root and shoot. It is called as crown. Transitional zone मतलब जिस जगह पे ये root और shoot मिलता है उसको crown कहते हैं. It is formed near the soil surface owing to elongation of mesocotyle regardless of depth of sowing. And these roots emanating from crown, they are called as crown roots. And that stage, growth stage, is called as crown root initiation. It is most important growth stage of wheat, which is highly sensitive to irrigation. That's why we should essentially irrigate at this crown root initiation stage, CRI. It is also called as CRI. And the shoot system, first one is stem. It is erect, cylindrical and smooth. It consists of nodes and internodes, and nodes are solid but internodes are hollow. Hollow means they are kali. And wheat system, it generally consists of 6 nodes. Basal internode is the shortest and subsequent are progressively longer. ये basal internode सबसे ज़्यादा छोटा होता है और बाकी सब उससे लंबा होता है. And length is around 30 to 100 centimeter in dwarf varieties. This is the length of stem. And the length of stem is around 150 to 160 centimeter in tall varieties. Leaf, each leaf is having sheath and blade. At the junction of sheath and blade, it consists of one ligule, single ligule, and 2 auricles. This ligule in wheat is very small. Next one is inflorescence. It is called as spike or ear, and it consists of main axis or rachis, around which 15 to 20 spikelets are closely grouped together in zigzag manner. Inflorescence means panicle, wheat panicle, and spikelets emerge from shallow depression on the rachis. And florets in each spikelet are enclosed by 2 glooms. They are called as lemma and pele, pele and lemma. Pele is slightly taller, means lengthy compared to lemma. And if an is present, it is attached to lemma. You remember this an, it plays very important role in dryland areas because it contributes photosynthesis. And grain, wheat grain is called as caryopsis, and it is generally oval in shape. Wheat grain consists of embryo, bran, and endosperm. One more thing is wheat grain, it is amber in color. Next one are growth stages. First growth stage is germination. After the sowing, when the wheat grain is exposed to moisture, it generally absorbs the water. After that, grain swells because of that moisture. And because of this swelling, this seed coat, it will be ruptured. And coleoptile, it grows downwards. And primary root pierces coleoriza and thrusts downwards. And germination generally takes about 5 to 7 days depending upon temperature. Sorry, here coleoriza it moves downwards and coleoptile it moves upwards, and coleoriza primary root will be formed from the coleoriza and stem shoot system will be formed from coleoptile. Next growth stage is crown root development, that is crown root initiation. It is the most important stage. It generally comes after 20 to 25 days after sowing. Exactly in most of the varieties 21 days after sowing. And coronal roots arise from the node of the first foliage leaf and it becomes the first node of the crown. And crown root initiation in dwarf varieties it generally occurs about 20 to 25 days after sowing. And adequate moisture is very important at this stage. That's why surely we should give first irrigation at this crown root initiation stage. Next one is tillering. First germination, crown root initiation, and next one is tillering. Tillering generally starts around 15 days after sowing and it continues up to 45 days after sowing. And new tiller will be added at every 4 to 5 days. ये टिलरिंग सोइंग करने 15 दिन के बाद शुरू होता है और 45 दिन तक चलता है और हर 5-6 दिन में ये एक नया टिलर ऐड होता है. एंड jointing is the peak plant growth stage. That means it occurs at 45 to 60 days after sowing. And internodes generally they become progressively longer. Internodes होता है वो elongation होता है jointing stage में. And uppermost internode it is the longest. Most of the grasses में jointing stage plant growth stage रहता है. Jointing मतलब just elongation of internodes. Next one is reproductive stage. It comes at 70 to 85 days after sowing and it is characterized by swelling of uppermost internode and flag. It develops completely at this reproductive phase and maximum leaf area of plant is observed at this reproductive phase only. Here two types of growth stages are there. Here we are seeing that flag develops completely at this stage. Because of this flag, topmost leaf will swell, that is called as booting. And followed by booting, this inflorescence it comes out of this flag leaf. That stage will be called as heading. Booting means just swelling of this leaf because of this flag, that is called as booting. And booting will be followed by heading root stage. Heading means this after swelling this inflorescence will come out of that flag leaf, that is called as heading. And seed rate for normal sowing generally 100 kg seed per hectare is required, but for late sowing and broadcasting 125 kg seed per hectare is required. For dibbling means generally we will do with the dibbler. For that one 25 to 30 kg seeds per hectare is required. But when soil moisture is less, seed rate should be increased by 25%. क्योंकि अगर सॉइल मॉइस्चर कम है तो जर्मिनेशन रेट बहुत कम होता है, जर्मिनेशन सही से नहीं होता है, इसलिए सीड रेट बढ़ाना पड़ेगा. इसलिए जब भी सॉइल मॉइस्चर कम है तो सीड रेट बढ़ाना ही पड़ेगा. और एक और चीज़ है कि सॉइल मॉइस्चर और फर्टिलाइजर एप्लीकेशन के बीच में रिलेशनशिप है, क्योंकि प्लांट अगर सॉइल मॉइस्चर कम है तो प्लांट अपटेक न्यूट्रिएंट अपटेक कम होता है. इसलिए अगर सॉइल मॉइस्चर कम है तो हम फर्टिलाइजर एप्लीकेशन भी कम करना पड़ेगा, लेकिन सीड रेट बढ़ाना पड़ेगा. And in case of FIRB means furrow irrigated raised bed. This one we will discuss later. 75 kg per hectare is sufficient. And the test weight of wheat grain it is generally about 40 grams. While test weight of Phalaris minor it is the most important weed in wheat crop. The test weight is 2 grams only. This Phalaris minor morphology is very similar to wheat crop. And sowing date, first fortnight of November is the best time for wheat sowing, and it varies from region to region. But most probably first fortnight of November is best time in most of the areas. और मान लीजिए एक गेहूं का वैरायटी है वो 120 दिन का है. अगर हम नवंबर में सोइंग किया तो वो फरवरी या मार्च फर्स्ट वीक में हार्वेस्टिंग कर सकते हैं, तो हाई यील्ड आएगा. और अगर हम दिसंबर में सोइंग किया, मान लीजिए हम दिसंबर में बुआई किया, तो हम अप्रैल में हार्वेस्टिंग करना पड़ेगा। और अप्रैल में क्या होता है, समर शुरू होता है, हाई टेम्परेचर प्रिवेल होता है अप्रैल में। और दिस वीट ग्रेन डेवलपमेंट स्टेज, मतलब ग्रेन्स वो हाई टेम्परेचर्स में हाईली सेंसिटिव है, इसलिए ग्रेन डेवलपमेंट सही से नहीं होता है। इसलिए लेट sowing it leads to yield reduction. That's why we should go for sowing of wheat in November first fortnight only. That means up to 15th November. And spacing, this is 22.5 centimeters. That is row to row
Excuse me,
spacing,
sir.
and 10 centimeters. That is
Excuse me, sir.
yes.
Sir, you told that yield reduction is due to late sowing. तो मतलब उस टाइम पे अप्रैल के टाइम पे हमारा टेम्परेचर इंक्रीज कर जाएगा, तो उससे उसकी यील्ड कम हो जाएगी वीट की।
ग्रेन डेवलपमेंट के लिए ग्रेन डेवलपमेंट होता है मेच्योरिटी स्टेज में। उस समय
ओके
में टेम्परेचर 25 डिग्री 25 डिग्री से ज़्यादा नहीं रहना है, इसलिए। लेकिन अप्रैल में उससे ज़्यादा रहता है, इसलिए ग्रेन डेवलपमेंट सही से नहीं होता है।
ओके सर, ओके, थैंक यू।
डू यू अंडरस्टैंड?
यस सर, थैंक यू।
And for rainfed areas, this row to row spacing will be 25 to 30 centimeter, 25 to 30 centimeters, and plant to plant centimeter spacing will be 5 to 6 centimeters. And the depth of sowing generally depends upon length of coleoptile, and coleoptile length is generally for a high yielding dwarf variety it is 5 centimeters. That's why this depth of sowing it should not be more than 5 centimeters. Depth of sowing it always depends upon length of coleoptile in wheat crop. And since the coleoptile length is generally 5 centimeters, depth of sowing should not be more than 5 centimeters. And if it is more than 5 centimeters, this seed it cannot come out of the coleoptile cannot come out of the soil. That's why germination will be poor or no germination will be there. And optimum, that's why the optimum depth of sowing is 2.5 to 5 centimeters. But in case of late sowing, depth should be around 4 centimeters only. Because if we go for deep sowing more than that, it delays the emergence of seedling by 2-3 days and delays the heading growth stage by 5 to 6 days. That's why optimum depth of sowing is 2.5 to 5 centimeters. In case of late sowing, it should be ज़्यादा से ज़्यादा तक 4 centimeters तक कर सकते हैं. Methods of sowing in wheat crops. How many methods of sowing are present? First one is drilling. Generally, it is the mostly followed method. Drilling of seed with the fertilizer cum seed drill. It is the best method of sowing, and seed drills can be calibrated at optimum seed rate. For drilling, around 100 kg seed per hectare is required, and broadcasting 25% higher seed rate is recommended, because we know broadcasting there will be no spacing, just we will generally broadcast the seed in the field. And commonly it is this broadcasting method of sowing, it is commonly followed in rice wheat cropping system, because after the harvesting of rice crop so much moisture will be present in the soil. For utilizing that moisture, just we will broadcast the seed in the field, so that this wheat it utilizes the stored soil moisture. Dibbling. Dibbling is used when limited seed is present. We have seen for dibbling generally 30 kg seed per hectare is required. It is done with the implement called dibbler, and but it is not used for commercial purposes because of high labor intensity and time consuming. It requires high labor and more time. Next one is behind the plow method. In this one, two types are there: Kera method and Pora method. In Kera method, first we will do ploughing with country plow. After the ploughing, just the seeds will be dropped with our hand. That is called as Kera method. And this Pora method, behind the plough, one funnel will be attached and seeds will be dropped through funnel. That is called as Pora. In Kera, hand will be used. In Pora, that funnel will be used. And this is FIRB, furrow irrigated rice bed. It is developed by a rice bed consortium of CGIR, that is Consultative Group on International Agriculture Research Institute. In this one, first beds will be prepared. This weed, it is sown on raised beds, and each bed 2 to 3 rows will be accommodated. Between the beds, furrows will be present. These furrows, they are used for irrigation. One important advantage of this FIRB method is it saves so much of water. And one more thing is seed rate is 75 kg per hectare. It is saving 25 kg seed per hectare. And weed, most probably it is grown in temperate and subtemperate regions, and it cannot be cultivated in soil orders like altisols and octisols, because these two soil orders, they generally present in tropical regions of world. Tropical means they consist of high temperatures, and wheat is a cool temperature crop. That's why it cannot be cultivated in soil orders like altisols and oxisols. Here we can see growth stage and optimum temperature required. For germination, optimum temperature required is 20 to 22 degrees centigrade, and for vegetative growth, for tillering jointing, 16 to 22 degrees centigrade is required, and for grain development, 23 to 25 degrees centigrade is required. As we discussed, if we harvest the wheat, it should be harvested in March crop, and temperature will be less than 25 degrees centigrade. And if we harvest the wheat crop in April or May, the temperature will be more than 25, it may reach 30 degrees centigrade also. That's why this grain development, it won't be good. Grains won't be formed and yield will be reduced. That's why we should sow the wheat crop in November, so that it will be harvested in the time. And temperatures above 25 degrees centigrade, they reduce the test weight of grain due to hastened maturity, means due to fast maturity ग्रेन डेवलपमेंट सही से नहीं होता है और टेस्ट वेट भी कम हो जाता है, अल्टीमेटली यील्ड कम होता है. क्रॉप्स में आप ये याद रखना है कि हर क्रॉप का सोइंग टेम्परेचर के हिसाब से करते हैं. मतलब आप देखिए राइस है, राइस मेनली खरीफ सीजन क्रॉप है, और व्हीट, लेंटिल, चिकपी, बार्ली, ओट्स, ये सब कूल सीजन क्रॉप्स है, रबी सीजन. क्योंकि व्हीट ये सब क्रॉप्स कूल टेम्परेचर प्रेफर करते हैं, और राइस मान लीजिए खरीफ और समर क्रॉप्स रहते हैं वो हाई टेम्परेचर प्रेफर करते हैं, और ये रबी सीजन क्रॉप्स है वो कूल टेम्परेचर प्रेफर करते हैं. इसलिए आप क्रॉप प्रोडक्शन में हमेशा क्रॉप यील्ड और टेम्परेचर का हमेशा एक रिलेशनशिप रहता है. आप उसी का हिसाब से पढ़िए, मतलब टेम्परेचर रिलेशनशिप के साथ. नेक्स्ट वन इज न्यूट्रिएंट मैनेजमेंट. High yielding dwarf varieties of wheat fully exhibit their yield potential only when supplied with adequate quantities of nutrients. That means balanced fertilization. Balanced fertilization is always required for achieving high yield. Balanced fertilization means it's just not only supplying nitrogen, phosphorus, and potassium, and along with these micronutrients, boron, zinc should be supplied, and sulfur should be supplied. Wheat crop which is yielding around 50 quintals per hectare, that means 5 tons per hectare, it generally removes 100 to 150 kg of nitrogen, 70 to 80 kg of phosphorus, and 120 to 125 to 150 kg of potash from the soil. And recommended dose for irrigated timely sown crop is 120 plus 60 plus 40, means 120 kg of nitrogen, 60 kg phosphorus, and 40 kg potassium per hectare. Means don't confuse that here it removes 125 to 150 kg potash, because wheat crop यहाँ soil से 125 से 150 kg पोटेशियम ले रही है, क्योंकि सॉइल में भी एन, पी और के रहेगा. उसी के साथ हम ये फर्टिलाइजर भी डालना पड़ेगा, क्योंकि इंडियन सॉइल से वो दे आर वेरी पुअर इन नाइट्रोजन एंड दे आर पुअर इन फॉस्फोरस आल्सो, and little bit potassium is present. So if it is removing around 125 to 150 kg potassium, and maybe it might remove, it is taking around 80 kg from soil, and we should add 40 kg with the fertilizers, and half of nitrogen, full dose of phosphorus and potassium, they should be drilled at the time of sowing. Means if we are sowing with seed cum fertilizer drill, Remaining half of nitrogen, it should be applied at the time of first irrigation. First irrigation, it is generally given at crown root initiation stage, that is CRI, at 21 days after sowing. Next one is weed management. Critical weed free period is up to 30 days after sowing. That means we should take care of that weed crop in first 30 days after sowing. Generally, monocot weeds affecting wheat are Phalaris minor, and it can be controlled by applying isoproteran at the rate of 0.7 kg active ingredient per hectare. But nowadays, Phalaris minor, it has started showing resistance against this isoproteran. It was reported by Dr. R.K. Malik at HISAR. And so, instead of this isoproteran, this sulfosulfuran, it can be used to reduce the population or to kill the Phalaris minor. Next one is Avena fatua, that is called a wild oat. To control this Phalaris minor and Avena fatua, post-emergence application of tribunil, it can be applied, but currently it is banned in India. These Phalaris minor and Avena fatua, these are the most affecting weeds in wheat crop. Next, dicot weeds like Chinopodium album, Anagallis arvensis, Melilotus alba, these are also affecting the wheat crop. For controlling these weeds, we can apply 2,4-ester salt as a post-emergency herbicide. We can apply it 30 to 35 days after sowing, that is 500 ml per hectare, to control these dicot weeds, that means mostly broadleaf weeds. Here you remember this one, just objection weed of wheat is Convolvulus arvensis, and associated weeds are Phalaris minor, Avena fatua, and Chinopodium album. And the horrible weed is Sorghum halipens, and satellite weed is Phalaris minor and Avena fatua, and absolute weed of wheat is Chinopodium album. These definitions, I think you know, objection weed, associated weed, satellite weed, absolute weed.
Sir, can you tell me the difference between satellite weed and associated weed? I'm not clear actually.
Which one, satellite weed and
Associated weed.
associated weed means generally it affects the associated means we cannot differentiate the morphology, or if weed crop is there, that weed will be present. That is why it's called as associated weeds, means it is always associated with the that particular crop. Means suppose one area is there, if you sow the wheat crop, generally Phalaris minor, Avena fatua, both will affect the wheat crop. That's why they are called as associated weeds. Means they are always associated with the crop. And this satellite weed means generally, like definition is there, it is affecting the crop ecosystem. It is the satellite weeds, they are present in the crop ecosystem. That's why they are called as satellite weeds. Means uh, for suppose a wheat ecosystem is there, that climate or that microclimate, it is favorable for this wheat growth. That's why they are called as satellite weeds.
Okay, sir, thank you.
And next one is water management. Wheat generally requires 300 to 400 millimeters of irrigation water, and number of irrigations, they vary from 4 to 6. And this table also, it is very important. Generally, if only one irrigation is present, you should irrigate the crop at CRI, that is crown root initiation stage, 21 days after sowing. And if two irrigations are available, we should irrigate the crop at CRI plus late jointing stage. Here at the bottom table, you can see that crown root initiation stage, it comes at 21 days after sowing, and the late tillering, it comes at 42 days after sowing, and late jointing, it comes at 60 days after sowing. Next one is flowering, it comes at 80 days after sowing, and milking, it comes at 95 days after sowing, and dove stage, it comes at 115 days after sowing. And
सर जॉइंटिंग एंड मिल्किंग स्टेज में क्या डिफरेंस है?
jointing means just it is a vegetative stage, and jointing means that is elongation of internodes.
Okay,
ground
sir.
thickness.
And
And
milking,
milking,
grain filling,
huh?
grain filling बोलते हैं milking को.
Just grain will be there, and that white color liquid will be there. First, it will fill the grains. That is milking.
And
Dove
सब
stage means
in
this liquid it will become hard in that dove stage. It will eventually turns into grain.
hardening of grain is called dowing stage.
Hardening of
Okay,
grain
sir. Okay, sir. Okay.
means that the liquid will change into that grain. That is hardening of grain. And uh, if only three irrigations are available, we should irrigate the crop at CRI plus late jointing plus milking. And if four irrigations are available, we should irrigate the crop at CRI plus late tillering plus flowering and milking. And if five are available, CRI plus late tillering plus late jointing plus flowering and milking. If six are available, we can irrigate. We should irrigate the crop at all six growth stages. Next one is border strip. It is the most commonly adopted method of irrigation, followed by check basin. But on sandy soils, only check basin method is followed, because border strip method it is not feasible on sandy soils, because in sandy soils generally macro pores will be high and drainage also will be very high. That's why border strip method it is not feasible. So in case of sandy soils, check basin method it is highly followed, most feasible. Now they have developed this FIRB also, furrow irrigated rice bed. If only less amount of water is present, then we can go for furrow irrigated rice bed, because it increases water use efficiency and it saves water. And sprinkler irrigation, it is also it can be used in wheat crop when border strip or check basin methods are not possible. Next one is yellow and dry straw. It is very important visual indicator for harvesting wheat crop. If straw tons are yellow and dry, then it is ready to harvest. And most suitable stage is when grains become hard and it contains 20 to 25% moisture. And optimum moisture content for milling and storage is 12%. For harvesting, it is around 20 to 25%. For milling and storage is 12%. Because if moisture is present more than 12% during storage, this stored grain pest will be there. They might affect the wheat crop. And hardiness of grain is determined by Perling index. Hardiness means grain should be hard. That means higher quality. So higher value of Perling index, it indicates the less kernel hardiness. So if Perling index is high, that means kernel is somewhat soft. So if Perling index is low, that means grain is this wheat kernel is hard. And here we already said that this wheat is mainly used for chapati making, bread making, and biscuit making. And for making these products, some qualities are required. Chapati making qualities like water absorption, dove color, dove properties, puffing. Puffing means just swelling, preservation, quality, taste, aroma. If all these qualities are good in that wheat, so we can go for preparation of chapati. And bread making quality, it is determined by high water absorption. If that flour means atta, it is having high water absorption capacity, so we can prepare the bread making. And that gas production capacity and gas retention capacity, it is also it should be more in that flour. If a flour is soft and weak, so it is suitable for biscuit making. And biscuit making, that flour should be having low water absorption capacity and high protein content. If all these qualities are present, so it is suitable for biscuit making. Here you see for bread making, high water absorption should be required. For chapati making also, water absorption should be high. But for biscuit making, this water absorption capacity should be low. Here you can see the differences between wheat and Phalaris minor. First, wheat basal node it is greenish yellow in color, but in Phalaris minor basal node it remains pink up to 50 days of plant growth. And in wheat, two auricles are present, which are mostly hairy, but auricle is absent in Phalaris minor. And in wheat crop, very small ligule is present, but in Phalaris minor, ligule is approximately 3 times bigger compared to wheat. And we know test weight is 40 grams in wheat, and in Phalaris minor, it is only 2 grams. Tillers, they do not branch in wheat crop, but in foliage manner, tillers does branching. And leaf color, it is generally dark green in wheat and light green in foliage manner. And it produces 60 to 70 seeds per plant, but it produces 10,000 to 30,000 seeds per plant. And seeds are amber in color and bigger in size. Here seeds are dark brown and oval in shape, and they are much smaller compared to wheat. But main 2 points are this basal node, it is greenish yellow in wheat crop and it is pink in color in phalaris minor. Mainly you can differentiate with the help of basal node. And next one is auricles. This phalaris minor, it is not having auricle, but the wheat is having two small auricles. These two are the main differences. But leaf color, it's very difficult to recognize through leaf color because it is dark green, light green, almost they appear similar. Thank you.
Thank
Thank
you,
you,
sir.
sir.